Welcome back. Today we're doing a deep dive into something really fundamental for writing solid Python code. Exception handling.
Mm-hmm. It's more than just basic try except, isn't it?
Exactly. We all know that for catching, those runtime hiccups, but are we really using it to its full potential?
That's the question. It's about moving from just reacting to errors to proactively designing dependable software.
Right. And to do that, we need to understand how Python signals problems in the first place.
It's internal language for oops, or maybe hold on a second.
Yeah, exactly. So there are two main kinds of signals, right? First up, the ones Python catches before your code even starts running.
Syntax errors,
Syntax errors.
like grammar mistakes.
Pretty much. The interpreter is like a very strict editor. It reads your code, and if it sees something structurally wrong, maybe a missing colon or parentheses that don't match up,
It just stops.
stops dead. It won't even try to run the code. It often gives you a hint about what's wrong. But yeah, execution halts until you fix that basic structure. Okay, so syntax errors are roadblocks before the journey begins. But what about errors that happen during the journey, when the program's running along fine and then bam,
Those are exceptions. Runtime errors.
like trying to divide by zero?
That's a classic zero division error. Or maybe you try to use a variable name you forgot to define.
Name error, seen that one a few times.
Or adding, say, a number in a piece of text.
Type error.
Yep.
Right. So what's Python actually doing when one of these happens?
Yeah.
It doesn't just silently fail, usually.
No, it doesn't. It creates something called an exception object. Think of it as a little package of information describing what went wrong.
An object.
Yep. And then Python raises this object. This immediately interrupts the normal step-by-step execution.
And if we don't do anything about it?
The program crashes abruptly, usually with a traceback message telling you where it happened.
Okay, so Python raises built-in exceptions. But we can trigger these ourselves too, can't we? Force an error.
Absolutely. That's where the raise statement comes in. You can explicitly tell Python, hey, this specific situation is an error condition.
Like if a function gets bad input.
Exactly. Maybe a function needs a list index, but the user gives one that's out of bounds. You could raise index error yourself.
You're basically defining your own error condition for that specific function's logic.
Precisely. There's also the assert statement. It checks if a condition is true.
And if it's false?
It immediately raises an assertion error. It's great for checking assumptions you've made in your pad, like this input value must be positive. It's a sanity check.
Okay, so we can raise errors, but the real magic, I guess, is in handling them, right? Catching them gracefully.
That's where the try, except else, and finally blocks come into play. This is the core toolkit.
So the try block, that's where you put the code that might, potentially mess up.
That's your potential danger zone, yes. You're telling Python, try running this, but be ready for trouble.
And if trouble happens, an exception is raised in that try block.
Control immediately jumps out of the try block, and Python looks for a matching except block.
Matching. So you can specify which error you want to catch.
Yes, and that's key. You can have multiple except blocks. One for value error, another for type error, maybe a general exception catch-all, though you have to be careful with that.
So you can react differently depending on the specific error.
Exactly. You can log the error, give the user a specific message, try an alternative approach. It prevents the crash and lets you manage the situation. You can even get hold of the exception object itself using except specific error as E.
As E. So you can look inside that object.
Yeah, you can inspect its arguments, print its message, maybe log the full traceback. It gives you much more context for handling or reporting the error.
Okay. What about else? I know that's sometimes there too.
The else block is optional. It runs only if the try block finishes completely without raising any exceptions.
This is like the success path?
Sort of. It's code that should run only if the potentially problematic code succeeded.
Got it. And then there's finally, that one seems important.
It's very important. The finally block is your guarantee.
Guarantee?
The code inside finally always runs. Always. It doesn't matter if an exception happened in try, whether it was caught by except, or if try completed successfully, or even if you return from inside the try, finally executes.
Why is that so crucial?
Cleanup. Think about opening a file. You need to make sure that file gets closed right. Even if an error occurs while you're processing it, finally is perfect for that kind of essential cleanup, closing files, releasing network connections, unlocking resources.
Ensures you don't leave things dangling.
Precisely. And while finally is the mechanism, Often the with statement in Python handles this even more cleanly for things like files. It uses context managers, which basically wrap the try.finally logic for you.
Ah, the with statement. That often makes resource management much neater.
It does. It leverages the same underlying principles, but often leads to more readable code for common resource patterns.
So pulling this all together, why should you, listening now, really focus on mastering this? It's not just about stopping crashes, is it?
Not at all. It's about building robust, user-friendly applications. Code that anticipates problems, handles unexpected input gracefully, and gives clear feedback instead of just, well, breaking.
It turns fragile code into something flexible, something resilient.
Think about it as giving your program a kind of poise. It knows how to handle bumps in the road without just giving up. It builds trust.
Keeps things running smoothly, gives users helpful information, makes your software dependable.
Exactly. It's a fundamental difference between code that just works sometimes and code that you can truly rely on in the real world.
So exception handling is really your program safety net, but also its way of communicating intelligently when things don't go as planned.
Well put. It allows you to manage the unpredictable. Without these mechanisms, how many complex systems would actually be usable? It's worth thinking about. Keep exploring it.